All right, everyone get ready, because today we're going deep.
Deep.
Like really deep.
Deeper than Rick's secret stash of mega seeds deep.
Into the wacky world of quantum physics.
We're talking quantum entanglement.
Delayed choice quantum erasers.
Superposition.
It's going to be a wild ride, so buckle up.
Just like that episode where Rick turns himself into a pickle, remember?
Hey, don't worry.
We know you guys are fluent in English.
So we'll keep things nice and simple.
Easy peasy lemon squeezy.
No confusing science jargon that would make even Rick Sanchez scratch his head.
You got it.
So if you ever watched Rick and Morty and thought, wait a minute, could any of this crazy stuff actually be real?
Right.
Well, get this. There's this mind-bending experiment.
Oh, yeah.
It's called the delayed choice quantum erasure.
It's a mouthful.
And it suggests that the future might actually be messing with the past.
Whoa.
Basically like that time travel episode where Rick accidentally creates a whole bunch of Cronenbergs.
Yikes.
But like on a subatomic level.
Sounds intense.
Oh, it is, believe me.
So where do we even begin with all this?
Okay, let's start with something super simple.
Okay.
Imagine you're chucking marbles at a board with a slit in it.
Yeah, I can picture that.
What happens?
Easy.
The marbles go through the slit, hit the wall behind it, and you get this nice straight line of marble hits.
Classic cause and effect.
Now add another slit to the board.
All right.
What happens?
2 lines of hits.
Exactly. Cause and effect, like, duh.
Obvious, right?
But here's where things get weirder than a plumbus factory.
Uh-oh.
Instead of marbles, imagine we're sending waves of water through those slits.
Oh.
One slit, you get a single wave pattern on the wall.
Makes sense.
2 slits.
Let me guess. The waves do something funky and make a bunch more lines on the wall.
You got it. They interfere with each other and create this crazy pattern with, like, multiple lines.
Because waves spread out and interact, right?
Yeah.
Totally different from those marbles.
Right, so scientists thought, hey, let's do this with light. You know how everyone knows light is made of tiny particles called photons?
Yep, those little guys.
They thought, well, photons are basically tiny marbles, so we should get the marble result, right?
Seems logical.
Nope. Instead of 2 lines, they got the wave pattern.
So light's acting like it's both a wave and a particle at the same time?
Right. It's like those quantum fidget spinners Rick is always playing with.
Ones that spin and teleport at the same time?
Exactly. But hold on, because it gets even crazier.
Oh, boy.
The scientists thought maybe it's because they're shooting a bunch of photons at once.
Uh-huh.
So they slowed it down and shot one photon one at a time.
What happened?
Even then, they still got the wave pattern.
It's as if each single photon went through both slits at the same time.
It's like each photon is having an existential crisis like, am I a wave or a particle? I can't decide.
Well, in a way, it's both. It's called superposition.
Superposition.
Yeah, it's one of the most fundamental principles of quantum mechanics.
Quantum mechanics.
Basically, it means a particle can exist in multiple states at once until we actually try to measure it.
So, like, it's both a wave and a particle until we, like, look at it.
Precisely.
Okay, this is blowing my mind already.
Just wait, there's more.
But what happens when we DO try to measure it?
Ah, that's where the delayed choice quantum eraser experiment comes in.
Delayed choice quantum eraser.
Catchy, right.
So the scientists wanted to figure out which slit each photon was actually going through.
Right, they were like, let's get to the bottom of this 2 slits thing.
So they were basically spying on the photons, like Rick using those surveillance cameras to watch Jerry in the bathroom.
Pretty much. But here's where it gets really wild.
Okay.
When they added the detectors, the photons suddenly started acting like particles again.
No way. So they were doing the wave thing, but as soon as they were being watched,
Straight back to acting like particles.
no more wave pattern, just 2 straight lines, like with the marbles.
Like they knew they were being watched.
Whoa, hold on. So just by watching them, they changed how the photons were acting.
That's the thing about quantum mechanics.
But does that mean, like, our minds are controlling reality?
Well, not quite.
Are we all secretly gods like Jerry in that simulation episode?
Not exactly.
Okay,
The observer, in this case, doesn't have to be a person.
so it could be anything.
Any measurement, even by a machine, can collapse the superposition, as they say.
Collapse the superposition.
It's not really about consciousness, but the act of measuring itself forces the universe to choose a state for the particle.
So it's not our thoughts directly, but the act of measuring something that makes it pick a side.
You got it.
Interesting.
But here's the really crazy part.
There's more.
They delayed the witch slit measurement until after the photon hit the wall.
Wait, what? They decided which slit to check after the photon already went through.
Exactly.
How does that even work?
I know, right? It makes zero sense in our normal understanding of cause and effect.
It's like deciding what you want for dinner after you've already eaten dessert.
But even with the delayed measurement, the results still changed. It's as if knowing the future, which slit we'll measure, somehow affects the past.
So the future is messing with the past.
It seems that way.
This is some serious time travel shenanigans. It's like those episodes where Rick goes back in time and accidentally changes the present. But wait,
Yeah.
if we're messing with the past, what does that even mean for reality as we know it?
Well, that's a question that's going to require us to go even deeper down the rabbit hole.
Deeper.
But first, let's take a quick break to let all this sink in.
Good idea. My brain's already fried.
We'll be back in a flash to explore even more mind-blowing quantum weirdness.
Can't wait.
Welcome back, quantum explorers. Ready for more mind-bending weirdness?
Oh, my brain's still reeling from the last round, but hit me with it.
All right, so last time we were talking about how measuring things in the quantum world is like forcing the universe to pick a reality, even if it means messing with the past.
It's like choosing between two equally awesome Rick and Morty episodes to watch. Tough choices, man.
It's more than just tough choices, though. This actually leads to one of the most mind-blowing implications of quantum mechanics, the multiverse.
Multiverse, you say? Lay it on me.
Okay, imagine this. Every time a quantum particle chooses a state, every time we make a measurement, all those other possibilities don't just disappear.
They stick around.
They branch off, creating their own separate universes.
So you're saying there's a universe out there where I actually aced my quantum physics exam. That's wild.
It is a wild idea. Imagine infinite universes all existing at the same time, each one slightly different based on every single quantum choice made.
Like there's a universe where Jerry's a successful entrepreneur instead of, well, Jerry.
Exactly. It's enough to make your head spin. We're talking a whole citadel of Ricks, but for everything.
So basically there could be a universe where I'm hanging out with a super smart version of myself and Jerry's winning Nobel Prizes. I need to find that universe.
It's a mind-boggling concept, for sure.
But hold on. If all these possibilities exist, why are we stuck in this reality? Can't we just hop between universes like Rick does with his portal gun?
That's the big question, isn't it? We're still a long way from understanding how to manipulate these other realities if they even exist.
So multiple universes, the future messing with the past. My brain feels like it's been through one of Rick's crazy experiments. Does this mean everything we thought we knew about reality is wrong?
It definitely challenges our everyday understanding of the world. The quantum realm isn't about finding definite answers, but understanding the likelihood of different outcomes. Instead of a neat, clear cause and effect universe, think more like a cosmic soup of possibilities.
So less like a perfectly organized IKEA bookshelf and more like one of Rick's chaotic inventions that's always on the verge of exploding.
Exactly. It's this fuzziness, this inherent uncertainty that makes quantum mechanics so intriguing and so challenging.
All right, speaking of challenging, let's dive into another mind-blowing concept. Quantum entanglement.
Oh yeah, entanglement is one of the weirdest parts of quantum mechanics.
Weirder than Mr. Poopy Butthole showing up uninvited to a party.
Possibly. Imagine two particles linked in a special way. We call them entangled. Now separate them by a huge distance like opposite ends of the galaxy.
Okay, I'm picturing it. Two tiny best friends separated by a vast cosmic gulf.
Now measure something about one of those particles, like its spin. Instantly, you know the state of the other particle no matter how far apart they are.
Hold up, are you saying they communicate faster than the speed of light? That's got to break some kind of cosmic rule.
It does seem to defy our understanding of physics. Einstein even called it spooky action at a distance. He wasn't quite sure what to make of it.
So it's not just theoretical. Scientists have actually seen this spooky action.
Oh, it's been confirmed in labs. We can create entangled particles and see this connection in action. It's one of the most mind-blowing but well-established phenomena in quantum physics.
Okay, this is officially weirder than that episode where Jerry gets a job at a place called Blips and Chits. But if we can entangle particles across galaxies, does that mean teleportation, like in Rick and Morty, is actually possible?
Well, not quite like jumping through a portal gun. Current teleportation research is focusing on transferring the quantum state of particles, not actually moving them physically. It's more like making a perfect copy somewhere else. Your information, your state, is used to create a new you.
So like a clone, but with all my memories and personality. Sign me up.
It raises some interesting philosophical questions, though. Are we just a bunch of information that could be copied and rearranged?
Whoa, that's a deep thought, man. My brain is officially fried.
It's a lot to process, that's for sure.
But we're not done yet, are we? There's got to be more to this quantum craziness.
Oh, there's plenty more to explore. We haven't even touched on the practical applications of all this yet, but we'll save that for next time.
Okay, guess I'll have to recharge my brain cells before our next deep dive.
Okay, my brain's still feeling a bit scrambled like a bad batch of Mr. Meeseeks, but we've covered some serious ground.
Multiverse, entanglement, time travel shenanigans.
We've explored all sorts of mind-bending quantum craziness that even Rick Sanchez would be proud of.
It's a lot to take in.
But before we warp out of this quantum rabbit hole completely,
Yeah.
let's talk about how all this wild science is actually changing the world.
You got it.
It's cool to explore the theories and all, but are there real-world applications?
Absolutely. Quantum mechanics isn't just some theoretical head-scratcher. It's leading to some seriously cool tech that could change everything.
So less head-scratching, more real-world applications. Give me some examples.
For starters, there's quantum computing.
Quantum computing. Is that like Rick's supercomputer, but even more powerful?
Imagine computers so powerful they make Rick's setup look like a child's toy.
Okay, color me intrigued.
Remember superposition, where a particle can be in multiple states at once?
Yeah, the whole wave particle thing. Well, regular computers use bits, which are either 0 or 1.
Right.
Quantum computers use qubits, which can be 0, 1, or both at the same time.
Wait, so they can, like, multitask on a whole other level?
They can tackle problems in ways that classical computers just can't.
That's like a million Mr. Meeseeks, all solving a problem at once.
A very powerful analogy.
So what kind of problems can these quantum computers solve?
They have the potential to revolutionize fields like medicine,
Medicine.
material science, artificial intelligence.
Well, hold on. You're talking about designing life-saving drugs.
Yeah.
Creating unbreakable material.
Very ideas.
AI that can actually think like a human.
It's all on the table.
This is insane. It's like going from a regular plumpus to like a whole fleet of spaceships.
It's a big leap forward.
What else is on the quantum horizon? What else can this stuff do?
There's quantum cryptography.
Cryptography, like codes and stuff.
It uses the principles of quantum mechanics to create super secure encryption.
So unbreakable codes.
Virtually unbreakable.
Even evil Morty couldn't crack these codes.
Highly unlikely.
That's awesome. No more worrying about anyone stealing my password for interdimensional cable.
Your secrets are safe.
Okay, what else?
Then there's quantum sensing.
Quantum sensing.
It uses quantum phenomena to measure things with incredible precision.
Like what kind of things?
Tiny changes in gravity, magnetic fields, even time itself.
Whoa, hold on. Are you saying we could detect alien spaceships with this?
Potentially, yes.
Before they even enter our solar system?
That kind of sensitivity is within the realm of possibility.
That's incredible. It's like having a superpowered version of Rick's portal gun, but for information.
It's opening up new frontiers in measurement and detection.
This is all pretty mind-blowing, even for someone who spends way too much time watching Rick and Morty.
It's an exciting field.
So what does the future hold for quantum physics? Are we on the verge of a quantum-powered world?
It's definitely heading in that direction.
Like flying cars and teleportation?
Maybe not quite that far, but as we unravel the mysteries of the quantum world, we're unlocking a whole new universe of possibilities.
It's like Rick always says, the universe is basically a giant ball of wibbly-wobbly, timey-wimey stuff.
And we're just beginning to understand the rules of that game.
And maybe, just maybe, we'll learn how to bend those rules a bit like Rick does.
The future is uncertain, but that's what makes it so exciting.
Well, folks, that's all the time we have for today's deep dive into the wacky world of quantum physics.
Hope you enjoyed it.
I know I did, even though my brain feels thoroughly fried.
It's a lot to process.
But seriously, if the quantum world has taught us anything, it's that anything is possible.
Keep questioning, keep exploring, and never stop wondering about the nature of reality.
And who knows, maybe one day we'll all be hopping between dimensions and building our own portal guns.
Until then, keep watching Rick and Morty and stay curious.
And that's a wrap from us. See you next time for another deep dive into the unknown.